Hello, you're welcome. All right, so now we are going to be looking at frictional force. Okay, now frictional force is one of the contact, or it's an example of a contact force. Remember, in physics, forces are being classified into a field force and, of course, contact force. Now, difference between field force and contact force is that every contact force is always in contact with the surface that is experiencing the force. In which one of them is frictional force? Okay, so what's frictional force? Frictional force is a force that actually opposes, okay, opposes, it opposes the relative motion, opposes the relative motion between two surfaces, between two surfaces. In contact, between two surfaces in contact. So which simply means that if we are dealing with frictional force, if we are dealing with frictional force, there must be motion, okay, between two surfaces. That means one surface must be moving against another surface, right? So let's take, for example, you actually place an object on a surface. For you to be able to, okay, apply a force to move this object along this surface, okay, you be able, this force is going to need to overcome the frictional force that is opposing the that will oppose the motion of the surface, right? And they discover that if this force that is pushing this surface is moving in this direction, then frictional force that opposes motion will always be moving in the opposite direction. Okay, so frictional force is always, the frictional force is always in opposite direction with the force that causes motion. All right, so I hope that is well understood. So invariably, for this body to move, then force must overcome the frictional force. Even when this force overcomes the frictional force, okay, and the body is moving, it will still be slowing down due to some frictional force known as dynamic friction. So that will now lead us to what is the types of friction. Okay, that leads us to types of friction. Now, friction is actually of two types. Okay, friction is static, either is a static friction or is a dynamic friction or kinetic friction. Of course, you should know the difference between the two. Okay, this one, static friction, is a frictional force that doesn't just oppose the motion, it opposes the motion to a point that it keeps, okay, is so strong that it keeps the body at rest. So it's a frictional force that is able to keep the body at rest, while kinetic friction only opposes the motion of the body. Okay, so kinetic friction actually only occur when the body is already moving, but only opposes the motion. So please take note. So invariably now, static friction is always greater than dynamic friction because static friction is strong enough to keep the body at rest. So keeps the body. So this suppose, okay, I have to correct this, the body at rest. So now let's proceed. We are going to be looking at the characteristics of frictional force. Characteristics. Now, one characteristic of frictional force is that number one is the fact that it opposes relative motion. Opposes relative motion. So the relative motion between two surfaces in contact. Number two is dependent. It is dependent on the nature of surface. On nature. And the nature of surface in contact, okay? In contact in that motion. On the nature. On the nature of surface. In contact. Okay, so which simply means that there are two types of surface. Okay, it's either the surface is smooth. If a surface is smooth, okay, then it has less friction. So a smooth surface will give you less friction. That will be less opposition to motion, okay? While rough surface, when the surface is rough, you have more friction. Then when the surface is when something is said to be perfect, okay, perfectly smooth surface. Smooth surface, perfectly smooth. Now at this point you have no friction or zero friction. Okay. All right, so now let's proceed. The next characteristic is that's number 3 now. Frictional force is independent. Independent on the relative velocity. Relative velocity. So relative velocity between the two bodies in contact. Remember, in frictional force, if you are dealing with frictional force, it's always a movement. It occurs when two bodies move against each other. Okay. So now number 4 is also independent of the area of the surface in contact. Independent on the area of the surface. In contact. Okay, independent on the area of the surface in contact. Then 5, the last but not the least, frictional force on the surface is directly proportional to the normal reaction. Frictional force on any surface is directly proportional to the normal reaction R. Now, we know very well that if an object is actually being placed on a surface, okay, that's the weight of the object actually acts downward. We talked about this when we treated Newton's second law, right? The weight of the object acts downward. But for this particular, okay, that's Newton's third law, not second law. For this surface to be able to withstand the weight of this object, okay, it must react upward with a normal reaction. Okay, so invariably, the frictional force you apply is proportional to the normal reaction. So the more the normal reaction of this surface, the more frictional force that is on this surface. So let's write that as a formula, and that will give us the formula of frictional force. Okay, so frictional force is directly proportional to the normal reaction of the surface. Remember, if we remove this sign of proportionality and bring an equal to, I have to introduce a constant. But this constant here is going to be this symbol. Okay, of course, this symbol I use mu to represent that. But what is this particular constant? It is called the coefficient. It's a constant called the coefficient of frictional force, coefficient of friction. Okay, so it's a constant that depends on the surface that you are considering. Okay, every surface have their individual coefficient of friction. And what I mean by surface is, okay, surface that is actually horizontal. We have two types of surface. We have horizontal surface. Then number two, we have an inclined plane. Horizontal surface, then an inclined plane. Okay, so we are going to look at how to determine the coefficient of frictional force, static frictional force in a horizontal surface and in an inclined plane. All right, that will be the next video. See you in the next video. Thank you.